Dear students, Assalamu alaikum. I am Dr. Farzana Shaheen from the Department of Chemistry at Allama Iqbal Open University, Islamabad. I extend a warm welcome to you for the first program of Fundamental of Chemistry, CHEM-3505, which will focus on the periodic table. So before we start, it is very important to highlight the profound importance of the periodic table. It's like a key to understand everything in the universe because everything around us is made up of the tiny building blocks which are called elements. So, if you are interested in the mystery of the universe, you need to understand the chemistry, and to understand chemistry, you need to understand the elements. And the good news is, it's way easier when they are neatly organized on the periodic table. So, think of the universe as a gigantic puzzle. The puzzle pieces are made up of something called matter. These matter pieces are like building blocks and are called elements. And these elements are built from tinier things called atoms. Now, let's go back in time. People didn't figure out the elements all at once, and they didn't even know what matter was made of right away. Instead, many intelligent people, each with their own ideas, worked together to figure it out. And they laid the foundation for what we know today about the matter and the elements. So, join us on the journey through the history as we learn about these tiny building blocks of the universe step by step. And thanks to the efforts of these clever thinkers. The story of the elements begins with Thales, who believed that everything in nature came from a single substance and he thought it was water. Later, Empedocles came along and said, there are four main things that make up everything, which are earth, air, fire, and water. Athenian philosopher Plato took Empedocles' idea and called these four things element. But it didn't stop here. Aristotle came along and took the things a step further. He looked at these elements and said, let's think about them in terms of hot versus cold and wet versus dry. He defined the Greek elements based on these characteristics, giving us a deeper understanding of what makes up the world around us. Now, for quite some time, people didn't really mess with the idea of those old philosophers. Things were pretty quiet, but then, in 1661, a fellow named Robert Boyle stepped in and changed the game. He said, elements were like the smallest indivisible building blocks of stuff, sort of like the building blocks of the universe. He thought these elements were made up of tiny particles of different kinds and sizes, kind of like nesting dolls. But he also said we couldn't open them up to see what was inside. It was a bit like a mystery waiting to be solved. So after a long pause, Boyle brought some fresh excitement to the world of science. Then after Robert Boyle, things got more exciting, and by the late 18th century, Lavoisier listed elements and 11 more were discovered, like chlorine, cobalt, nitrogen, oxygen, etc. From then on, they found a new element about every 2.5 years. Lavoisier defined the elements as something you can't break down with the tools of his time. Mendeleev further clarified the pictures of the element and saw them as a substance made of atoms with the same weight. The journey continued with more discoveries and new ideas about what elements are. Antoine Lavoisier holds very eminent position in terms of his contribution towards the formulation of the periodic table and in the development of modern chemistry. In 1789, Antoine Lavoisier wrote a book with the title Traité élémentaire de chimie, in which he included 33 elements, including light, caloric, argil, etc. He grouped the elements based on their properties into gases, non-metals, metals, and earth. Now, let's dive into the fascinating world of Jacob Berzelius. He was a true laboratory genius. In 1818, he achieved something extraordinary. He unlocked the exact weights of atoms of 45 elements out of 49 known elements of his time. But Berzelius didn't stop here. He was an explorer in the realm of chemistry, discovering new elements like thorium, silicon, cerium, and germanium. If he were on a scientific treasure hunt, revealing hidden gems. On top of it all, he simplified the complex world of elements by creating modern chemical symbols. He used simple alphabets to represent elements, making it easy to understand. Before John Jacobs Berzelius, the elements were symbolized in a different complicated manner. Like you can see, these are some symbolic representation of the elements which were used before Berzelius, but Berzelius made them easy. For example, the iron is the word, the nomenclature, the name which was, or the symbol which was used for iron in Swedish was Jan, Eisen in German, Fer in French, and Ferrum in Latin. And Berzelius gave it the symbol Fe. Similarly, tin was abbreviated or pronounced as ten in Swedish, Zinn in German, etain in French, and stennen in Latin. And the Berzelius simplified it and gave it the symbol Sn. Then John de Bruiner, between 1780 to 1849, first time attempted to organize the elements in some particular manner. He proposed that certain group of three elements exhibited similar chemical properties, with middle element having the properties averaging of the other two. For example, in the alkali metal triad, for example, lithium, sodium, and potassium, the properties of sodium are intermediate between lithium and potassium. But de Bruiner could make only 5 such triads, and it was not accepted by the scientific community. His triads were limited and eventually surpassed by more comprehensive periodic table development. However, this early attempt to find patterns laid the groundwork for the later development in the periodic table by scientists like Dmitry Mendeleev.